are Team Tech Matrix Solver, and here we are here to present our solution on Smart India Hackathon 2025. Our project addresses the challenge of identifying the taxonomy and assessing biodiversity from the environmental DNA dataset. We have developed a AI-powered tool that revolutionizes how we discover and monitor our ecosystem. So, what is environmental DNA? Every organism leaves behind the genetic traces in its environment. By analyzing this, we identify species without needing to capture them. As the study of Sussex, University of Sussex, that eDNA is incredibly effective. It detects three times many marine species compared to the traditional with traditional video surveys, and was significantly faster, requiring 1.5 minute per species detected versus 8 hours of species detected. This highlights the immense potential of the eDNA for rapid and comprehensive biodiversity assessment. Here is the code solution of our end-to-end eDNA pipeline. The diagram is colored with the color coded to show what is demanded by the problem statement, what we have added as a participant, and the hybrid components. So the blue, the demanded problem statement. The problem statement requires a system that could handle the sample collection, DNA extraction, sequencing, pre-processing, and taxonomic assignment to assess the biodiversity. These form the foundational steps of our pipeline. Then the green, we have enhanced this foundation with the advanced technology. This includes everything: our cloud infrastructure and AI model training pipelines to our interactive dashboard and real-time system. Then yellow, these are the system where we have blended required components with our own innovation. A prime example is our hybrid taxonomy assignment, which combines traditional method with machine learning or improved accuracy and novelty detection. Next, the sampling and sequencing. It starts with the research vessel in the water is collected and filtered. The DNA is then extracted, sequenced using either the portable nano mini ion or for on-the-spot analysis, or a lab Illumina for engineering. The raw DNA reads cleaned and processed. We then convert these sequence into the numerical representation called embeddings, making them ready for our AI model. This is our key innovation line. We use machine learning to cluster the sequence, and most importantly, to detect novel DNA that doesn't match with the known species in our existing database. This is crucial for discovering new life form. Then the data modeling and training. All the data are stored in our scalable cloud platform and environment. Our continuous training pipelines ensure that AI models are always improving and new data comes. Output and visualization. So finally, we have translate the complex data into the actionable insight through an API that feeds into dashboard, GIS map, and automated stakeholder. Then feasibility and viability. So our project is both feasible and viable. Feasibility. So the core technologies in the sequencer, cloud computing, AI tools are matured and readily available. Our pipeline is designed to scalable and starting from and growing as needed. The combination of edge and cloud processing allows us to both rapid and field result and deep analysis. Viability. So the this system offers immense scientific value by enabling discovery of new species. It provides the policymaker is economically sensible and reducing the reliance on expensive lab infrastructure. There is a strong market potential to offer this as a service to research institution and government agency. Next, impacts and benefit. The impact of our AI-driven eDNA system extend across multiple sectors. For scientists and researchers, it accelerates the discovery of new species. For policymaker, it provides the reliable data to support the conservation law and monitor ecosystem health. For academia, it offers a rich data set for the research and education. For the tech community, the pharma industry, for the tech community, it drives the innovation at the intersection of AI and genomics. The pharma industry, it opens doors for discovering novel biomolecules. For society, it raises awareness about the biodiversity, and promote environmental sustainability. So, in conclusion, for our Smart India Hackathon 2025, it is more than just a tool. It's a comprehensive platform addressing the critical needs for the better biodiversity monitoring. By integrating advanced AI and a robust technical architecture, we provide system that is feasible, viable, and impactful. We are confident that our team will significantly advance the marine science and conservation effort. Thank you. We are ready with your question. If any question.
Okay, today we're diving into the eDNA pipeline static website. It's this really comprehensive demo of an environmental DNA analysis pipeline for marine biodiversity.
Right, tracking species through the genetic traces they leave behind. It's impressive tech.
Definitely. And the challenge we're seeing is how to make all that technical brilliance immediately engaging for someone just landing on the site.
Yeah, I see that.
So this website, it really shows off a robust system, from the sampling stage right through to the final ecological analysis. It's technically complete, loads of features, you can see the effort there.
Absolutely. It lays out the technical side very clearly. I do wonder, though, how does that hit a first-time visitor? Someone maybe not already deep into eDNA terminology. Does that immediate technical depth maybe delay engagement?
Exactly my thought. The initial presentation, especially on that main index.html page, it jumps right into the tech specs and the feature list, which is accurate, totally accurate, but it might kind of skip over the why should I care part for some users. And since this is a demonstration, an educational tool, you really want to grab them with a story first, right?
Right. You need that hook.
So our suggestion is to maybe reframe that opening. Instead of leading with, bullet points of features, what if it started with a really compelling question about marine life?
Or maybe even a striking visual. Something from the dashboard.html showing the results.
Yeah, or like a dynamic banner that quickly animates the process sample collection, analysis, the problem it solves, then you get into the technical solution. Could even be something like a short, interactive day in the life of eDNA journey on that first page.
I like that. Making the impact clear before the specs. Okay, so moving on. What about the getting started section? The notes suggest it aims for ease of use.
Yes, it makes a strong claim about being easy to get started with, whether you're just exploring the demo or setting it up locally. The structure notes are detailed.
Okay, but let's think about that ease of use claim. Easy for who exactly? It feels like it might be mixing instructions for quite different users together.
That's the core of it, yeah. The current getting started works really well for a developer. Someone who wants to clone the repository, set up a local server, all that info is there.
But for a general user, someone who just wants to click around the live demo as intended?
For them, those developer instructions are, well, less relevant. They could even muddy the waters a bit, hiding the simple path, which is just open the file and explore.
So it creates a bit of unnecessary friction for the casual explorer.
Precisely. So the suggestion here is pretty straightforward. Clearly separate the information. Have distinct pathways. Maybe one heading like experience the live demo or begin your eDNA journey.
Right, with super simple steps.
Exactly. Like 1, open index.html in your browser. 2, click through the pipeline steps. 3, explore the interactive dashboard. Boom. Then have a separate, clearly marked section, developer setup or contribute with all the current technical instructions.
Makes the main path instantly clear. Good. Okay, third point, the visualizations.
Yeah, and this is a real strength. The range is impressive. Bar charts, pie charts, line graphs, scatter plots, heat maps, geographic maps, it's got the lot. Clearly a robust approach to showing the data.
It's definitely comprehensive. But how well does the material connect that breadth of visualization types to the actual unique insights someone can get from them, especially the interactive parts? Is the superpower of the interactivity really highlighted?
That's the question, isn't it? While the site and the README list all these visualization types as features, it doesn't quite spell out how this interactivity, this variety, actually helps someone understand eDNA analysis better.
Or how it helps uncover patterns that, a static image just wouldn't show.
Exactly. The so what behind the interactive nature needs to be stronger, especially for a demo designed to educate.
So the suggestion?
We think integrating a narrative around the specific value of these visualizations is key. Explain how they uniquely help with understanding or discovery or making decisions in the eDNA context.
Could you give an example?
Sure, like on the dashboard.html itself or next to certain charts, maybe add little callouts, insights gained, or why this matters. So next to that scatter plot for novelty detection, you could explain explicitly how clicking and exploring helps spot emerging threats faster than just looking at a fixed picture.
Okay, I see. Or for the taxonomic assignment part?
Right. For the taxonomic stuff, maybe show how the visualizations of phylogenetic placement give a much more intuitive feel for species relationships than just staring at raw data tables. Really sell the benefit of the visual interaction.
Got it. Highlighting the why behind the what.
So overall, the eDNA pipeline website is a really solid, technically impressive demo.
Definitely.
To quickly recap our suggestions.